Hi students, I hope you are doing well. Okay, today we are back with a new video related to Pythagoras theorem. So far we discussed, as I discussed with you in the last classes, we have important theorems in triangles, which is very important for your examination purpose. So that we discussed it, right? So among that we have Pythagoras theorem is one of the expected theorem. You can it may come for your exams. Okay. So before going before like explaining the proof of Pythagoras theorem, you should understand, okay, what basically this Pythagoras theorem, how do we, prove it? It means to do, for example, you want to, like last cases, we proved area of similar triangles, and we proved basic proportionality theorem and its converse also. So before proving that, okay, before proving that area of similar triangles, I explained you what is the AA similarity and also what basically a similarity concept is. So because you should know what do you mean by, you should know what exactly a similar triangle is. Similar triangles are, then you can easily prove the, areas of similar triangles, theorem. Means if you don't know the proof of that, don't know the properties of similar triangles, you are not able to prove that, because that is a basic thing which you need for the theorem. Here also, before going to this Pythagoras theorem, you should understand one more theorem. Actually, this is as a theorem you have, but no need to study this or no need to remember this. Remember you have to do, but no need to study, as this is not as much as important like your Pythagoras theorem. But this is the basic for this theorem. Okay, to prove Pythagoras theorem, you should know this. Without this, you cannot prove Pythagoras theorem. Okay. So what is this statement? The statement is, if a perpendicular is drawn from the vertex of a right triangle to the hypotenuse, then triangle on both the sides is perpendicular. Both the sides, the perpendicular are similar to the whole triangle and to each other. Okay, anyway, I'll explain you. Maybe this is long statement actually. Statement is long, but proof is very simple. Like explanation is very simple. Okay, this is a right angle triangle. Okay, maybe this is right angle at B. Correct? You just turn this and check. You will understand. So, like you imagine, you cannot turn this, but you imagine that. So, this is a right angle triangle ABC. What I am doing, I am just drawing one perpendicular from a vertex C, and triangle ABC. In triangle ABC, which is the longest side, by looking at the triangle, you can easily see that AC is the longest side. So for AC, I drawn from this ABC are called vertices and B is called a vertex. So from B, I drawn one perpendicular. Okay, B I draw a perpendicular. So this perpendicular means everybody knows it makes 90 degrees. So when you draw a perpendicular at one vertex, which is B, and always remember, from vertex to the hypotenuse you should draw. So this is one vertex and we drawn a perpendicular to the hypotenuse. Hypotenuse is what in a right angle triangle? Longest side is hypotenuse. So for this three sides, AB, BC and AC, AC is the longest side. So of course AC should be your hypotenuse. So AC we draw a perpendicular from B. So this is dividing triangle ABC into two different triangles. What are those? One triangle is ADB and another triangle is BDC. Okay, we got two triangles here. How? Because of this perpendicular, correct? Because of the perpendicular BD, because you drawn a perpendicular BD, so this perpendicular is dividing the triangle ABC into two different triangles. What are those? One is triangle ADB, another triangle is BDC. Okay, so these two triangles, this is one and this is two. And here guys, just you look at this figure, we have three triangles. What are those? Including triangle ABC, correct? So according to this theorem, what they are saying, triangle, if this happens, if once you draw a perpendicular to the hypotenuse from any vertex, so this triangle ADB is similar to triangle ABC. Okay, triangle ADB is similar to triangle ABC, and as well as triangle ADB is similar to triangle, okay, BDC also. It means this triangle formed is similar to the other triangle also, and also similar to the ABC. Correct? The triangle ADB is similar to triangle ABC and also triangle BDC. Okay? I hope you understood. Next triangle, what is another triangle? Triangle BDC is similar to triangle ABD as well as triangle ABC. Okay? You can write like this. Triangle BDC is similar to triangle ABC as well as, means triangle BDC is similar to triangle ABD or ADB. Okay? What you understood? This actually, when you draw a perpendicular from one vertex to the hypotenuse, so this perpendicular will divide the triangle ABC into two different triangles. What are those? ADB and BDC. The form a triangle. The triangles which are formed are similar to each other and also they are similar to triangle ABC. That is the meaning of this statement. Okay? It means, I'll explain once again. Okay, this is the, you have to understand this. So this is how, this only we are going to discuss, use in Pythagoras theorem proof. Okay. So what is this? Triangle ABD is the one triangle and triangle BDC is another triangle. According to this theorem, what it states, triangle ABD is similar to triangle BDC, correct? And also triangle ADB is similar to triangle ABC. This is one thing. And this triangle BDC formed is similar to triangle ADB also and also ABC. Okay, this is the proof. Okay, I hope you understood. So what we are doing, we are just drawing a perpendicular from vertex to the hypotenuse. This perpendicular divides this triangle into two different triangles. What are those? ABD and BDC. The triangles which are formed, what are the triangles formed? ADB. This ADB is similar to triangle ABC, also similar to triangle BDC. First thing. Next, triangle BDC, which is the second triangle formed, is similar to this first triangle, and this third triangle is ABC. I will just easily explain to you once, like one more, like easy method. You see, this triangle we take it as 1. This triangle we take it as 2. This whole triangle we take it as 3. Okay, it means triangle 1 is similar to triangle 2, and triangle 1 is similar to triangle 3 also. This triangle 1 is similar to triangle 2 and triangle 1 is also similar to triangle 2. Similarly, triangle 2 is similar to triangle 1 and also for 3. You remember this. Okay? It means two triangles are formed. Correct? So this one triangle is ABD, second I taken as BDC, whole ABC I taken as third triangle. So it means triangle 1 is similar to triangle 2 and triangle 1 is also similar to triangle 3. Next, triangle 2 is similar to triangle 1 and triangle 2 is also similar to triangle 3. This is the theorem which we discuss now, statement which we discussed. Okay, this we are going to use in the Pythagoras theorem proof. So how we are using? First, we have to write the statement. Okay, what is the statement says? Okay, statement says, in a right angle triangle, or in a right triangle, you can write like this. In a right triangle, okay, the sum of, or the square of, I don't know, the square of hypotenuse is equal to the sum of the squares of other two sides. Okay, I'll just repeat the statement. In a right triangle, the square of hypotenuse is equal to the sum of the squares of the other two sides. So this is the, okay, theorem statement. So here what is the right triangle? Right triangle means right angle triangle. So right triangle is ABC. So in ABC, what are the, don't take that BD. BD we are not assuming, just you take ABC only. So ABC, which is the highest, like longest side, AC, correct? This is statement we have to prove. Okay. Before that, let me write. Given triangle ABC is right angle triangle. Okay, ABC is right angle triangle. They only given this, and to prove, what we have to prove? We have to prove that AC square is equal to AB square plus BC square. This we have to prove. Okay. So what exactly we are telling here? See, the statement you observe, in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So in the triangle ABC, and they clearly told that ABC is a right angle triangle. And this Pythagoras theorem is applicable only for right angle triangles. You cannot apply this theorem for any other kind of triangles. It means we cannot apply this for obtuse angle triangle or acute angle triangle. This theorem is applicable only for right angle triangle. Okay, that you have to understand. And given ABC is a right angle triangle. In this, which is the longest side? As we discussed before, AC is the longest side. So that is considered as hypotenuse. So statement, what the statement says, in a right triangle, the square of hypotenuse, it means what is hypotenuse here? AC. So AC square is equal to the sum of the squares of the other two sides. What are the other two sides here? AB and AC, correct? AB and AC are the other two sides. So AC square means hypotenuse square is equal to the sum means addition, sum of square of AB, because AB and BC are the other two sides. So AB square plus BC square. I'll repeat the statement. This Pythagoras theorem states that the square of the hypotenuse means longest side, which is AC. For example, if we take ABC triangle, AC square is equal to the, what are the other two sides of triangle ABC? AB and BC. It means AC square should be equal to the AB square is sum of AB square plus BC square. It means what we have to prove? We have to prove that AC square is equal to AB square plus BC square. Okay, so that we have to prove. So now proof. As the proof is very simple. You have to use the theorem like statement which we discussed before. Okay, it is based on that. Here, as we discussed in that theorem, we have three triangles in that. What are those? One is ADB, another one is BDC, and obviously we have one more triangle. From that triangle only we got this triangle, which is ABC. So proof. What we are considering here, we will consider, or you can write that triangle. Okay, from the above theorem. See, I am writing above, or from the theorem above. I am just writing above as this. Above may be your 8.1 or the we can consider some name for this. Okay, fine. Or you can use the theorem. That is also fine. Okay, I am writing above because we don't know the theorem. Exactly the number. So from the theorem, or you no need to write this actually. Every time no need to consider, directly we can write, no problem. So triangle, okay, we know that, just you write like this, we know that, okay, from this triangle directly I am taking. So we know that triangle ADB is similar to triangle ABC. Okay, triangle ADB is similar to triangle ABC. Why we know that? Because we know that they should be similar to each other, because just before this theorem proof we discussed that, like ADB should be similar to triangle ABC, correct? So if two similar triangles, these are obviously similar triangles. So if they are similar triangles, what is the first two letters here? AD by AB, correct? AD by AB should be equal to AB by AC. See here, clearly observe, whenever I am taking these two similar triangles, ADB and ABC. As we know that they are similar, and we discussed before why they are similar. And first two letters AD. Here, what is the first two letters? AB. Like this only you should write ratio. AD by AB. Last two letters AB and last two letters here is whatever you are taking, which letters you are taking, same corresponding letters you are taking. So this you take it as one term, and here cross multiply. If you cross multiply, it will become AC into AD, which is equal to AB into AB. Can I write AB into AB as AB square? This we take it as equation 1. And also we know what is the next thing we know. This ADB is similar to triangle ABC, and also triangle BDC is also similar to triangle ABC. So this condition I am using. Okay, triangle BDC is also similar to triangle ABC. So if they are similar, their corresponding sides should be proportional. So for next two letters I am taking. Here also I should take next. I can write this CD as DC, both are same. So CD divided by BC. See, here I am taking last two letters. Here also I should take last two letters. Okay, CD by BC should be equal to, okay, here, and what is the next? Here I am taking BC, first and last. Okay, first letter and last letter, and here also same thing, BC by AC. Okay, so you can ask me, sir, why are you taking CD only? Why can't you take other two? Okay, remember we are taking in such a way that we should get hypotenuse here. Okay, see, hypotenuse related sides only I am taking. See, one side AD, another side DCC. In that case I taken AD. In this case I taken, okay, CD. Got it? AD I taken there. See, here you observe AD I taken. Here I observe CD I taken. So this side I need and this side I need. Means which are lying on the hypotenuse, those sides you have to take. Remember, you cannot take others, not required. So for the proof, what are the sides we required? AD, you can observe here. Which are the sides lying on the hypotenuse? AD is one side, so these two sides I am taking. And also, we need this also, BC we need, and AB we need, because this square only is equal to this one. So that's the reason I need this side, see, everywhere. AB also there, BC also. Like that you have to assume. You can ask me, sir, one more side also ratio is there, why or not? We don't want that. For the proof, it is not required. So whichever is required for the proof, we are taking that, and we are not going against the rules also. Okay? So basically what sides we are taking? AD, okay, and AB, next DC and BC. Very simple. AD, AB, AD, AB, DC. Okay, you can remember like this. So CD by BC is equal to BC by AC. Just cross multiply. AC into CD is equal to BC into BC. BC square. BC into BC. BC square. CD into AC. Correct? This you take it as equation 2. Okay? This theorem is very simple. If you understand, add 1 and 2. Equation 1 and equation 2, we are adding. So adding means we have to add LHS and RHS. So AC into AD plus, here is what? AC into AD. What? AC into AD by, AC into AD plus AC into CD. Correct? There LHS is AC into AD. Here LHS is AC plus AC into CD. Plus, what is their RHS? AB square. Sorry, equal to AB square plus BC square. Correct? We are adding the LHSs of both, which is equal to RHS. I hope you understood. Okay, AC plus AD, their LHS. Here is AC into CD. Here LHS. So add both LHS separately and add RHS also. Okay, and if you are getting confused with us, you can see like this. Just like equation, I am adding AC into AD is equal to AB square. Next, AC into CD is equal to BC square. So when you add, what happens? This 2 should be added and this 2 should be added, right? Whenever you add this plus this should be equal to this plus this. So same thing. So here you observe AC is the common side in both. So take common, which will be left with AD plus CD. Okay, AC into AD plus CD is equal to AB square plus BC square. Okay, so what is AC plus CD? AD plus CD, AD plus CD. Here, AD plus CD is AC, correct? So AC into AC is equal to AB square plus BC square. AC into AC is obviously AC square. So AC square is equal to AB square plus BC square, hence proved. That's all. This is only you have to prove. Okay, it's very simple theorem, easily, and most of the times in your board exams they ask this theorem. Okay, most of the times Pythagoras theorem is very commonly they'll ask. Usually for almost all the board exams. Okay, not every board exam, usually. Okay, it's an expected theorem. Yep. I'll just explain once again. See, as to know this theorem or to prove this theorem, you should know the basic theorem which we discussed, basic statement which we discussed before. That is the main thing you have to understand. That again I'll explain. See, actually a perpendicular is drawn from a vertex B, okay, to the longest side AC, means hypotenuse. One perpendicular drawn from B to AC be drawn. So what happens when you draw this triangle is divided into two different triangles. What are those? ABD and BDC. After that, what I said, triangle ADB is similar to triangle ABC. One thing. And also triangle ADB is similar to triangle BDC. And also triangle BDC is similar to triangle ABD as well as triangle 3, which is ABC. So this we have to remember. So this is only we are going to use in the Pythagoras theorem. So what statement of Pythagoras theorem says? In a right triangle, the square of hypotenuse is equal to the sum of the squares of other two sides. Mean, if you consider triangle ABC as a right angle triangle, in this triangle, what is the hypotenuse? AC. So AC square is equal to, what are the other two sides? AB plus AB and BC. So according to the Pythagoras theorem, AC square means hypotenuse square is equal to the sum of the squares of other two sides. Other two sides means AB, BC. So means AC square is equal to AB square plus BC square. It means hypotenuse square is equal to the sum of the squares of other two sides. Usually students where they will do mistake, what I observe usually, in a right triangle, they'll write this, in a right triangle, the square of hypotenuse is equal to the squares of other two sides, they'll write. I hope you understood the mistake. Like what mistake they'll do usually. They'll write in a right, some people will not write in a right triangle, one thing. Some people will write this concept or this sentence, in a right triangle they write. The square of hypotenuse also they'll write, everything else, they'll not write this, sum. What is the meaning of it? If you don't write sum, it is, or they are multiplying there, no right. So if you don't write sum, that is completely wrong. So statement should not be written on own. Why we say that statement should not be written on own? Maybe if you write correctly, no issues. Sometimes you guys may miss the key point. This sum in a right angle triangle, okay, squares. Okay, these are the key points of this theorem. So this cannot be missed. You cannot, if you miss those, they will just ignore the, like theorem. Whatever you written, they will not even think. First, if you make a mistake in the statement itself, they will think this guy don't know the statement, so what he can. Even though if you've written everything correctly, they may not consider. Okay, you may get less marks. No, depends on the corrector who corrects the paper. So that's the reason. So don't do that kind of mistakes which will make your statement or make your theorem wrong. Okay. So what we were discussing. So to prove what is given actually in this case, they only given ABC is a right angle triangle. As I discussed with you, this theorem is applicable only for right angle triangles. You cannot apply this for any other kind of triangles. Obtuse and acute, we cannot apply this. And what we have to prove? We have to prove AC square is equal to AB square plus BC square. So how do you prove? For this proof, as I said, we are using before statement what we discussed. We know that triangle ADB is similar to triangle ABC. Yes, you know, right? This triangle, whichever is formed by the perpendicular BD, this ADB is triangle similar to triangle ABC. So these are the key points we should remember. ADB is similar to triangle ABC. Write ADB only, don't write ABD. Problem is here. Okay, what do you guys can think? Sir, ADB, ABD, both are same. No, why can't you write ABD? write ADB because in congruency 9th standard you might have studied. Corresponding sides when you take, you will take letters like this, AD, AB. If you write AB here, it will come AB, AB. That will not help you to prove the theorem. So that's the reason, go in the flow. ADB should be similar to ABC. We have to take like that only because corresponding sides we need, AD and AB. We don't want AB and AB as corresponding sides in this case. So AD, first two letters you take. AD, next two letters is AB. So AD by AB should be equal to last two letters, AB and AC. So AB by AC. If you remember this which triangles are similar, your theorem is almost done. Okay. So ADB is similar to ABC. So that's why AD by AB is equal to AD, AB by AC. And here I did cross multiplication. Cross multiplication how many? Just AD into AC or AC into AD is equal to AB into AC. This cross multiplication you might be knowing. For example, x by 3 is equal to 3 by 2 means cross multiplication will become 2x is equal to 9. 2 into x, 2x, 3 into 3, 9. This kind of thing only we are doing here. You might have studied in equations. Okay. Understood? AD into AC or AC into AD is equal to AB into AB, which is AB square. This you take as equation number 1. Next, as we know that this triangle is similar to triangle ABC and also this triangle BDC is also similar to ABC. Correct? Not only this triangle similar to ABC and BDC, which triangle, another triangle formed is also similar to ABC. Because condition also I am taking. So triangle BDC is similar to triangle ABC. One thing you observe, both the cases I taken ABC. Okay, here also ABC is there, there also ABC. Okay, again BD. Here I am taking CD, okay, or DC. DC divided by BC means DC divided by BC because DC is the second two letters here. Here again remaining two letters BC. So CD by BC is equal to BC. First and last is equal to divided by AC. Again that first and last in the other triangle. So why we are taking only these two triangles? I told you clearly guys. Here we need the sides which are on the hypotenuse. What are those sides? AD from the triangle ABD and DC from the triangle BDC. So that is the reason we need AD. So that is why I have taken AD. Correct? We need only this side and this side. AD, AB, CD, BC. Just to remember AD by AB, CD by BC. Everything else. Okay? So now that's the reason we are taking only those two sides. So what we know, just use cross multiplication. AC into CD is equal to BC into BC, which is AC into CD is equal to BC square. This I take an equation 1, that you take as equation 2. Add 1 and 2. Both the equations you add. When you add, just like this, you remember. Whenever you add, for example, x, y, 2, 3, add means what you do? X plus y, correct. Whenever you are adding, right hand side, your left hand side also add, and right hand side also. So it becomes x plus y is equal to 5. Correct? No. X plus y left hand side, 2 plus 3 right hand side. Similarly, there also this plus that right hand side. So left hand side. So AC into CD plus AC into CD, AC into AD plus AC into CD is in LHS and RHS is what? AB square plus BC square. So AB square plus BC square. In these two things which is common, AC is common. So take AC common. If you take AC common, you will be left with AD plus CD. So AD plus CD is equal to AB square plus BC square. And AD plus CD, here you observe AD plus CD is a full side AC. Correct? AD plus BC is AC. As we know that. So just you substitute that. AC into AC is equal to AB square plus BC square. And AC into AC is what? AC into AC is AC square. So AC square is equal to AB square plus BC square. At last we proved that the hypotenuse square is equal to the sum of the squares of other two sides. That is the proof. It's very important proof. Okay. I hope I don't want to say this more times. Important. Okay. So that's the thing. You have to practice and remember this. Okay. I hope you understood this. Thank you very much. Please like, comment, share and subscribe to our channel. Thank you very much.